Thank you. So hi everyone, I'm Ella. First of all, thanks Petra for the previous talk. I feel like it was a great starter for what I'm going to talk about. I feel like she just led the stage for me. So thank you, and I agree 100% with the things that she said, and looking forward to cooperate in the future. So let's start from the top. I'm Ella. I'm very excited to be here. What a great community you guys have here at OWASP London. I'm super grateful for being here. So as Sam mentioned, I'm a data scientist, and true fact, I'm actually a physicist. So I'm just excited about engaging in complex problems, whether it's quantum mechanics or cybersecurity. And I've been a data scientist for quite some time now in different domains, from e-commerce to legal tech and application security. Right now, I'm leading the data science team at Apiro, an ASPM platform that gives you full visibility into your source code and help you prioritize and mitigate your security risks. Okay. So I'm going to talk about secure by design. I'm going to talk about what does it mean to do the secure by design process, what are the challenges, and how we can use AI to automate that process. So a lot of things from previous talks are kind of getting the dots connected. And I really love for you to ask questions during the lecture if you have any, if you want to comment or ask something, if you want me to dive deeper into something I've said. Let's make it more interactive and less of a monologue. That'll be great for me. Right, so let's start. All right, so when we're talking about application security, we can, definitely identify risks when they are in your production environment. And, we can identify exposed secrets, unauthorized APIs, sensitive data being written to logs, and those kind of things. When they are already in your production environment, then first of all, they can be exploited, which is not great. And it's also going to take a lot of time and effort to fix them. It has to go through the entire SDLC process before the risk can be fixed, and it's a tedious process, and we don't want to get to that point. So sometimes we're trying to prevent the risks from entering the production environment by scanning your pull requests, and that way, risk doesn't go into the production environment, but still code was being written and has to be fixed. So the dream is, what if you could prevent unsecured code from even getting into your pull request? And what if the developer had the countermeasures and the security concerns in his mind when he's writing the code? Now, that would be the dream, right? And that's exactly what secure by design means. It means that we're proactively looking and finding risks before development begins. Now, I think it got tremendous potential, like Petra was saying. And the secure by design process includes threat modeling. And just to have like a quick glance, I'm sure there are some experts in here. So, sorry. So when we're conducting a threat model process, we start by mapping the assets and what we want to protect in our application. And then we will try and think, okay, how would this new feature that I'm developing going to look like having some kind of a diagram or a flowchart of how it would look. And that point we're going to, that's like third step, is actually the hardest, where we wreck our brains on what could go wrong and where are the exploitation points and how an attacker could exploit them. And after we're done with the third part, then we have probably like 1 billion risks in our mind, and we have to prioritize and think, okay, what should I handle first? What's the most important one? How am I going to make sure each and every one of them is not entering my code? And fix your design accordingly, right? So the first, the last few steps are kind of iterative until you have all your concerns kind of covered. And I think, like Petra mentioned, if this process was happening for all the feature designs that you have in your application, then, I mean, we can all agree that the code would be much, much safer, right? Yeah, nodding, thank you. Thank you. But in real life, can you throw a number as to how many companies engage in threat modeling processes, like in percentage? Okay, what's the percentage of the companies that do secure by design and threat modeling processes? 20%, okay, 5%, okay. Well, I think I kind of like you said, maybe, because when I was hearing that 30% of the companies are doing it, I was underwhelmed. I was thinking, how can it be that less than a third of the companies engage in secure by design and threat modeling processes? Because it holds so much potential. It could really prevent so many risks from entering the code. And when we stop it at an early stage, we save so many resources, right? So for me, it was shocking that less than a third of the companies are actually doing it. And the next question was why? Why do so little companies do it? What are the challenges? Why is it not happening always? Because it has so much potential. And so there are quite a few problems that we've mapped out. I think, like also Petra mentioned it, it takes a lot of time to conduct that process. So you cannot, I mean, most companies don't do secure by design and threat modeling processes for all the features that are being released, not even the important ones, because they don't have time for it. And there's not a real process of how we're making sure that we're reviewing all the important features and how we know that the steps we're pointing at are actually being taken into consideration. And it's hard, right? I mean, the diagram I was showing of how to do a threat model, you really have to know a lot, both about your application, but also about the threats that are out there. So it's not an easy task at all. And I mean, if you had all the time and knowledge in the world, then you might have been able to, to resolve it and to overcome all of these challenges. I mean, just like to take a subjectivity, you could have 5 threat modelers working on the same feature and do a majority vote and having the best threat model in the world, not subjective. But you don't. You rarely have one threat modeler to work on a single feature. So for me, it all boils down to scale, just having too much and not being able to do it. And when it's a problem of scale, then this is where AI shines, because this is really where LLMs and AI can come in hand and help in that scaling issue. Any questions so far? Going for the modeling here. Okay. So this also kind of, I think, points out the problem where just yesterday, the CEO of Google said that 25% of, I wanted to ask you what you think the percentage is. Okay, never mind. So 25% of the code written in Google is written by AI, 25%, and now we're 2024, okay? It's only gonna get worse from that point. And, we can't keep up with that pace. It's so much code that is being written. There's so many features being developed at every point in time. Even though my product manager always tells me there's too little features we're developing, and I'm telling him, no, there's so much. And okay, that's just another work thing. And it's really hard to keep up with the pace of coding and features and do a proper threat modeler for each of them. And if I tell a joke, you can laugh. Okay, it's really allowed, recommended. Okay, so we wanted to solve the issue of scaling secure by design and threat modeler processes. And we have, it took a lot of trial and error. It took a lot of time and a lot of thought, talking to a lot of our customers and understanding what we want to do and how. But eventually we got the problem kind of nailed down to this process, but it's been a journey. And it's a process where we take all the features, design, contextualize them, and having them go through 3 steps. I'm going to elaborate on each one. Please stop me if you have any questions, okay? Okay. So the first step is detection. Now, sorry, just let me get a sip of water. No. Right? Okay. So the first step is detection. Now, this is where the first few iterations of secure by design for us were only focused on the first step because it's a super non-trivial one. We're looking at all of the design tickets that a company has, and we're trying to find which tickets are the ones that are interesting for review. Which ones are the important ones, the ones that might introduce new risks into our systems. And when we studied that subject, we found that about 1 to 10% of the tickets will be those kind of tickets that we want to look at, because obviously we don't want to look at all the tickets that we have in our ticketing system, right? A lot of it is going to be garbage that doesn't need to be reviewed, but we want to find the ones that might introduce risks into our system. And that's super subjective task because different practitioners have different ways of defining it, right? So we came up with this long list of questions that we want to ask ourselves when we're doing the detection process. And we want to ask ourselves, okay, is there going to be a new API introduced? Is there going to be a change in an existing API? Is there going to be sensitive data handler? Just like a bunch of those questions. And also we ask which application is it going to go into, because that has a lot of weight in that decision as well. And finally, we did an experiment where we took 3 analysts and we gave them the same group of tickets, and we asked them to do the detection themselves and say, what do they think should go through review and what shouldn't? And what do you think was the level of agreement that the 3 analysts had? How much? Okay, but let's say like in percentage. 10%. Okay. Well, again, you're yeah, it's a little bit drastic, but they agreed on, because they had a very clear set of guidelines, so they weren't just operating on out of thin air, but they had a 50% ratio. But as a data scientist, when you have data that's agreed upon only in 50%, then it's gonna be a challenging task. Because the data, you don't know what's the true data here, what tells the true story. And we can't have 3 people constantly tagging tickets. So at this point, and again, as I've said, the first few versions, we were only doing the detection phase. And that low agreement level has made us realize that the first step is not enough. We have to do more. We have to understand. And what does it mean to understand? It means that we're going to add another step. Okay, not only we have an LLM that does the detection of tickets that should be going through security review, now we're going to understand them better. We're going to classify them into a category. For example, sensitive data handling, user permission, architectural changes, network, etc. And we're going to create a textual, human-readable explanation as to why this ticket was chosen. Okay, so that way, the person that's looking at the section can, understand the logic, kind of see behind the mask of why this decision was made. Okay, and that's the second step. So we're detecting and we're understanding the detection. Now, at this point in time, it was just a few weeks before launching this feature, and we were kind of proud of ourselves, opening up a champagne. Yeah, you figured it out, all right, and that's awesome. And then the product manager was like, why are you celebrating? You have so many features to develop. And thank you. And then just weeks before launch, Idan, our CEO, comes up and says, can you try and generate some security review questions? Maybe you can try and generate a threat model. And again, weeks before launching the feature, we're like, okay, we can try. And we did. Those were a few hectic weeks, but we taught the LLM to create specific security review questions on that ticket. And we taught the LLM to create threat model stories. And then once we did it, we looked at it and we said, okay, now it makes sense. Now we're actually doing so much. We're detecting, we're understanding, we're mitigating, we're creating countermeasures, we're helping the security practitioners to understand what's important to review, giving them guidelines for how to review it, and creating that conversation between the developer and the security practitioner where, it's all automatic and there are different models doing those work. And that makes sense to us. Okay, so questions so far? Okay. So just another short demonstration of what the entire flow looks like. So we're looking at all of the tickets that we have in ticketing systems, and we're combining them with the source code where it's going to be developed. We're ingesting everything into our models, and as the 3 steps I've shown before, we are detecting, understanding, and mitigating. Now, I think that in this point, we're ready to see an example of the entire process start to end. Unless someone wants to ask something. Okay. All right, so let's look at an example. Now, the process I've showed of detecting, understanding, mitigating is happening all the time for every single ticket that is being opened in the ticketing system or ticket that is being updated. Every time we run the algorithm again and connecting those steps. Now, my example will start with a ticket being opened. It's a little bit small, so I'll tell you what it says. It says that we want to develop chatbots with AI. Sorry, that's my gig, and we're going to develop a chatbot with AI that's going to do customer support. Now, our customer support guy, Ori, if you're listening, it's not a real ticket. We're not going to replace you. Don't worry, it's just a fake ticket. Okay, we're not going to replace you for now. So this ticket says we want to develop a chatbot with AI that's going to do customer support, and the chatbot is going to assist the customer, and so it will have access to customer data like orders and accounts, etc. Right now, okay. Now let's say I'm developing this feature, and actually I always wanted to develop a chatbot with AI, so let's do it sometime. Let's say I'm developing it, and I'm just starting to experiment. Okay, so I opened like this draft pull request where I'm experimenting, I'm doing some stuff, testing, and I've linked my pull request to the ticket. So now the ticket contains both the information of the pull request, and it can also contain a link to the repository. So we know that the code that is going to be written, that is described in the ticket, will reach, in this case, the limb repository, which is our repository in Appiol. And now this is where the next step is, for me, most exciting, because this is where all the magic happens. I mean, it's not really magic, it's hard work of a lot of people for a lot of time. But when we, in Appiol, when we analyze source code, then we have this huge inventory of APIs, of sensitive data classes, of authorization application security measures, and we know a lot of things about the source code. We know a lot about the repositories, and here you can just see a summary, but we know where the code is going to be integrated in, and that gives us a lot of context to understand the ticket, okay? Because you agree with me that if I was implementing the code in, I don't know, a test repository, mock repository, experimental repository, just for data nerds like us, then, and it's not exposed, not internet exposed, then maybe we wouldn't classify this ticket as risky. Why? Maybe we wouldn't want to have a security review of that ticket. So the context is everything for us in Appiol. Like we say, context is king. I know here Charles is the king, but in Appiol, context is king. And now I have all this information that I can reach the ticket with. And by the way, we don't have to have it. I mean, we can have the entire process happening even without a pull request connection and a code connection. So in this point, I have all the information about the ticket, and I have all the information about the source code, and this is where we're going to activate our first LLM, which is the fine-tuned proprietary LLM that we trained. And it's going to say, I mean, it was trained to answer it has one job, to answer one question. How certain are you that this ticket should go through a security review process, secure by design process? And in that case, the confidence is 0.94. It answered that it's 94% certain that this ticket should go through a security review process. And this is relatively high, so we classify this ticket as risky and being a candidate for security review. Now, what's really cool about here is that the ticket was created on July 11, which is the same date as the risk was created. So we have, and it's just within the hour. I mean, it's a matter of running a few LLMs, and you have all of this process for all of your tickets all the time. You don't have to wait for someone to go over it, and it gives you so much power of scaling up and automating that process. So at that point, we're going to activate our second LLM, which is going to, again, classify to a category and create a free text explanation as to why this ticket requires security review. And it gives you, again, this kind of inside information as to why this decision was made. And you can choose if you want to agree with it or you disagree. And if you disagree, then we're going to learn for next time, okay? Kind of a feedback loop. And again, this LLM also uses both the information of the ticket and also the information in the source code. All right, next step is creating security review questions. And just think that those security review questions can be automatically copied into a comment on the same JIRA ticket that was created. So you get the conversation between the developer and the security practitioner starts, conversation starts rolling, and the developer is more aware of what are the measures that they have to deploy in their code. And just when the code is starting to be written, I mean, no single line was written at that point maybe, and already we have, actionable questions that the developer can have in mind when he's writing his code, her code. And I think that's like a revolution in a way. Like, oh, sorry, can you repeat the question?
No, you were saying that this information you've gathered, you basically training them at some point. Train them, then you basically assign them, you basically put them into the vector. How regularly do you do this?
You mean how often do we train our models? That's a really good question. So whenever, I think the question is how often do we train our models? And first, I mean, before we released the feature, then it was trained up to that point. And then once we gain enough data, we're going to do a retraining, or once we see that the model starts, to perform in a manner that is unsatisfactory. Let's say we get a lot of negative feedback, or we're seeing that the performance is degrading, then we're going to initiate a retraining phase. And I think those are the main points in time. So I think, this is super powerful, okay, where we can again automatically at no time get security review questions and also a threat model created for every interesting, kind of a risky ticket that is initiating a design, that is initiating development. And we can have the code being written where there are certain countermeasures already taken in hand before development begins. Okay, I think that's super powerful. And here you can see, for example, the automatically created threat modeling stories. So we're talking about a chatbot that uses AI. So for spoofing, we can say that there is a danger of impersonating a legitimate user and stealing their sensitive data. And for tampering, we can suggest intervening in that space between the model and the backend service, and there are more. And just, this is just a summary. We've walked through why secure by design and threat model process are beneficial, why are they important, but then on the other hand, why are they not happening all the time everywhere? And then I've shown how we can use LLMs, large language models, and AI in order to automate that process and aid in that way. And what it gives you the ability to have to know all the tickets, like all the designs that are happening, which ones are going to be risky, which ones might introduce risk into your systems, and then contextualize them with the entire world of Piro's deep code understanding, having to know where they're going to be deployed, why are they being risky, and but not only that, but also having those countermeasures and remediation steps generated automatically. So that's it. Hope you enjoyed it.
You mentioned confidence. I have a question for you. Every time I use LLMs and I ask them the question, how confident are you? What I'm getting in response is actually a hallucination. So many times I ask something and say, how confident are you? And it gives me like 98%, but the answer is totally wrong. So the question is, have you come across this problem with LLMs? And what are the methodologies or techniques that you're using or people can use to overcome this Gen AI problem of hallucinating or making up the confidence level?
Okay, that's a great question. Thank you, Sam. I think, well, first of all, hallucination, definitely huge bummer, gonna agree on that. But I think that specifically when it comes to confidence, then I agree with you. It's very hard to get LLMs to say how confident they are. And the reason that we are getting it is because it's a fine-tuned LLM that we've trained ourselves. So we've actually given it thousands of data points where, you get the ticket, you get the code context, give us a number. Like, don't give anything else, just give us a number, like thousands of times. And it was trained that way. So that's why in that case it works. But I agree, it's an issue.
Yeah, so the question is does the change of the temperature help the confidence level?
I think in this case, what helped the confidence level was just the fact that it was, fine-tuned with data that, you tell what's the input, what's the output, like that's the answer for that. But decreasing the temperature definitely helps on other cases as well. And it's a technique we're also employing along with changing other hyperparameters, but it's also.
But on-train model, I think, was very important because so many people just using ChatGPT and they're just using RAG and they don't provide their own training data. Oh, yeah.
But I'll say something about that.
So yeah, thank you very much. I'm wondering whether you had a chance for some of the customers to try this and what sort of feedback you've had from customers.
So actually, I have a guest here who can speak for that, but I don't know. I don't want to put him on stage. I don't want to frighten. So we just had a meeting today, and we've actually got good reviews. I think they were saying that if it wasn't for that feature, then they just wouldn't look at designs and they wouldn't have time for it otherwise. I mean, it's something that unless they are being kind of fed with that information, and unless the system tells them what's interesting, what they should look at, then it just wouldn't have happened. I mean, and that's the case for so many customers, because it's an important process, but a lot of the time it's like, who has the time for it? And we try to make it as as easy as possible for the customer. So for example, you can get an alert when a new risky ticket is added. You can have that security questions automatically be a comment on the ticket. So like just everything, I'm sorry, Sam, just everything in order to bring it to them. Yeah, just to make it happen. And I just wanted to say one more thing, because you were talking about, okay, but most of the people don't have data and they use GPT. I think that in today's world, it's also very easy to create data. And first of all, I'm all in for Petra's idea of creating kind of a shared data set. But I'll just tell you a secret. One of the methods that we use to get data is to generate it automatically with GPT. So you can ask GPT. I know everyone's like, oh. But it works, okay? You can have GPT create like, I don't know, 1 million Jira tickets in a second, and then you can review it, okay? You can give it some notes, okay? I want it to be more realistic. I want it to be on that use case. I want it to like think you're a developer in that company, and okay, it works. I mean, obviously it's not the only data we use. It's just we're enriching sometimes our system with it, but it's a method, and inviting you all to try it and then train your own models. It's becoming easier every day, really.
Awesome. We had one more question here.
So first, have you tried using other of those right? Or so for your friend model, I've seen that you use right? Have you tried any other approaches or blended together somehow? Results of it. The second, have you looked into using multiple agents in like open previously last month? For this month, they showed about slowing, so kind of putting a cluster of different agents working together. Have you tried anything this year?
Okay. Thank you, Sam. So, okay, 2 questions. One, we've been using Stride so far, but I really like the idea of using more and combining them. I think we're also, because it's just a start. I mean, we're constantly developing and we're in kind of a beta phase. So I think we're playing with the idea of even for different threat models, also creating more actionable countermeasures, and we keep on thinking what more context can we create, what more information can we create that would be extra helpful for the person that's getting it. So loving the idea, totally. And the second question was, do we use example of OpenAI having like an orchestration of agents, right? So in that case, we're actually using 2 different LLMs. So we have like a chain of, different large language models are doing different tasks. Each one is trained to be on specific, their own kind of, okay, this is your input, this is your output. So it's a chain. It's not a chain of agents, but it's a chain of models in that case. I don't know if it's answering the question.
Great, yeah. I see there's one more question here.
Actually, I was having 2 questions. So one was covered by Sam already, like about how do we deal with the false positive. So now my question is like, how can we detect potential business logic bypass in related case cases?
Ooh, that's very good.
Wait, how do we detect what? How do we?
How detect the business logic bypass, right? The business logic vulnerability.
If one user is using
Oh, well, I mean, we're going to, okay. So I think we're going to ask the questions, and raise those stories that ask, those questions and raise their attention. And then we can also show, I don't know, either the developer or the security practitioner, we can show what are the security measures that are taken in this repository, because we also scan the code, so we know does it have like this repository, which kind of authentication, authorization method it has, and then it all just comes together as to what should be protected. Is it already protected? Should you be protecting it now? Was that clear?
Okay, so that's the, okay, do we have a question? Yeah.
So you showed how the model thinks the ticket is risky, and these have to go to the model thinks the ticket isn't risky, also explain why, and is there a for feedback? Yes.
Thank you. Okay, so you're asking, sorry, if I understand correctly, you're asking about false negatives, right? Okay, yeah, that's a tough one. I agree. It's a good question. So if the model doesn't think that that the ticket is worth reviewing, then we're not going to show it. But I have a few buts here. First of all, we are filtering that detection phase by a threshold, okay? Because we have that confidence level, and we're gonna say if it's above threshold, then show it to us. If not, then don't. So first of all, that threshold, it can be altered, okay? So if you wanna have more tickets, you're more, I mean, it's a matter of what's more bothering you, false positive or false negatives, right? I mean, you're gonna have either, because life. And you have to decide. So I think, first of all, each one can decide for their own if they choose more false positive or more false negatives by altering that confidence threshold. That's the first. And then second thing, we're constantly going to look, you know, in our internal, when we're questioning ourselves, we're always looking at that phase, like a little bit above and below the threshold and what's going in there. And then we're trying to understand, did we miss things that were just in the in-between?